all to Think Maths. We are in class 10 Maths, chapter 7, coordinate geometry. In this session, we are going to discuss about the example problems 1 to 5. So, example 1, do the points 3, 2, minus 2, minus 3 and 2, 3 form a triangle? If so, name the type of triangle. So, to check this, so we should check whether it is a triangle or not. So for 3 points to be a triangle, it is nothing but sum of two sides should be greater than third side. So this is the condition for a triangle. So next one is, if it is a triangle, we have to find out the type of triangle. So we know that there are three type of triangle. Equilateral. So what do you mean by equilateral triangle? It is nothing but all sides will be equal. So all sides will be equal in an equilateral triangle. So another triangle is isosceles. In isosceles, two sides will be equal. So next one is right angle. So what do you know about right angle? So in right angle, we have this side as hypotenuse. That is opposite to 90 degree is hypotenuse. So this is the base and this is the perpendicular. So this is the right angle triangle. Okay, so these are the three type of triangle. So if you want to prove it is a equilateral triangle, we should show that three sides are equal. So if it is isosceles, two sides will be equal. So for a right angle, we have the condition hypotenuse square equal to perpendicular square plus base square. So this is the condition for three types of triangle. So first let us check whether it is a triangle or not. So let me name the points as A 3, 2, B minus 2, minus 3, C as 2, 3. So I have named the triangle. We have to find out the distance between the points. So we have A, B, C. So if you take a triangle A, B, C, we have to find out distance between AB, BC and AC. So uncheck whether it forms a equilateral, isosceles or right angle. So first let us check if for AB. So the distance formula is square root of x2 minus x1 whole square plus y2 minus y1 whole square. So this is the distance formula. Here it is x1, y1 and this is x2, y2. Okay. So what is x2 minus x1? It is minus 2 minus 3. So minus 2 minus 3 whole square plus y2. y2 is minus 3, y1 is 2. So it is minus 2 whole square. So which is equal to minus 2 minus 3 is minus 5 whole square plus minus 3 minus 2 is also minus 5 whole square. So minus 5 whole square is 25 and minus 5 whole square is also 25. If you square negative, it will become positive. So plus it will become, so 5 square is 25. So 25 plus 25 is root 50. So you can write this as root 50 or you can write this as 25 into 2. So 25 is a perfect square. So you will get 5 root 2. So we got AB distance. Next we have to find BC. So when we go to BC, so this will become the first coordinate x1, y1 and this will become x2, y2. So let me erase this. So this will become x1, y1 and this is x2, y2. So it is square root of x2 minus x1. So 2 minus, already another negative is there. So minus 2 whole square plus y2 minus y1. So y2 is 3 minus 3 whole square. So square root of 2 minus into minus is plus. So 2 plus 2 whole square plus 3 minus into minus is plus. So 3 plus 3 whole square. So you will get 2 plus 2, 4 square plus 3 plus 3, 9 square. So 4 square is 16 and 9 square is 36. So 16 plus 36 is 52. So it is square root of 52. So this can be written as 4 into 13. So 4 into 13 is 52. So it is 2 root 13. So what happened? We didn't get AB and BC are equal. So even two sides are not equal. So we should check for another side. Suppose AC will be equal to one of the sides. So let us check whether it is equal or not. AC is equal to, so now this becomes x1, y1 and this becomes x2, y2. So let me erase this first coordinate for B. So x2 minus x1. So here 2 and 3. So 2 minus 3 whole square plus y2 minus y1. 3 minus 2 whole square. 2 minus 3 is minus 1 whole square. 3 minus 2 is 1 square. So minus 1 whole square is 1. 1 square is 1. So it is root 2. So we didn't get three sides equal. So it is not equilateral. And two sides are also not equal. So it is not isosceles. So let us check whether it is right angle triangle or not. So we will do that in the next page. So far we got AB is equal to 5 root 2, BC equal to 2 root 13, AC equal to root 2. So if you check AB plus AC, so AB plus AC is 5 root 2 plus root 2, which is 6 root 2. BC is 2 root 13. So we will get AB plus BC AC will be greater than BC. So that is sum of two sides is greater than the third side. So if it is so, if this condition satisfies, then ABC is a triangle. So we proved that ABC is a triangle and we have to check whether it is right angled or not, because it doesn't satisfy equilateral. All three sides are not equal. Isosceles, any two sides are also not equal. So we should check for right angle triangle. So let us take this right angle triangle A, B, C. So let us take these two sides, AB square plus AC square. So AB square plus AC square. So AB square is 5 root 2 whole square plus root 2 whole square. So 5 root 2 is 5 square is 25. Root 2 whole square is 2. So 25 into 2 plus root 2 square is 2. So 25 into 2 is 50 plus 2. So 50 plus 2, 52. So 52 is nothing but 2 root 13. Okay. So we wrote root 52 as 2 root 13. So this is nothing but 2 root 13 whole square. So which is nothing but BC square. Okay children, because root 52 is nothing but 2 root 13. So just 52. 52 is nothing but root 52 whole square. So 52 will be 2 root 13 whole square, which is nothing but BC square. Okay. So we got AB plus AC square. So AB is 5 root 2. AC is root 2. It is equal to the hypotenuse BC, which is 2 root 30. So this is the base, this is the perpendicular, and this is the hypotenuse. So we got h square equal to, h square is BC square. So BC square equal to perpendicular square plus base square. So base square is 5 root 2. 5 root 2 is AB. So AB square plus perpendicular is AC. So AC square. So that means triangle is right angled. So we get right angled triangle. Okay. So I hope you can understand this problem. So moving on to the next example in the next page. So what is this? Show that the points 1, comma 7, 4, comma 2, minus 1, comma minus 1 and minus 4, comma 4 are the vertices of a square. So if 4 points lie in a square, we have all four sides. So if this is a square A, B, C, D, so if it is a square, we should have all sides equal. AB equal to, BC is equal to, CD is equal to AD. So all sides should be equal and their diagonal should also be equal. So that is AC is equal to BD. So if it is not equal, then this quadrilateral will be a rhombus. Okay, so if it is a square, diagonal should be equal. So let us check this. So first let us name the points A of 1, comma 7, B of 4, comma 2, C of minus 1, comma minus 1 and D of minus 4, comma 4. So what is the distance formula? Distance formula is square root of x2 minus x1 whole square plus y2 minus y1 whole square. So AB distance. So this is x1 y1 and x2 y2. So 4 minus 1 whole square plus y2. So 2 minus 7. 2 minus 7 whole square. So 4 minus 1 is 3 square plus 2 minus 7 is minus 5 whole square. So 3 square is 9 and 5 minus 5 whole square is 25. So 25 plus 9 is 34. So let it be root 34. So next let us find BC. So BC is equal to square root of x2. So this is x2, this is x1. So minus 1 minus 4 whole square plus y2. y2 is minus 1, y1 is 2. So minus 1 minus 2 whole square. So this is nothing but minus 1 minus 4 is minus 5 whole square plus minus 1 minus 2 is minus 3 whole square. So minus 5 whole square is 25, minus 3 whole square is 9, which is equal to root 34. So we got BC is equal to root 34. Let us check for CD. So CD is equal to square root of minus 4 minus minus 1 whole square plus y2. So y2 is 4 minus y1 is minus 1. So minus 1 whole square, which is equal to minus 4 minus into minus plus 1 whole square plus 4 minus into minus, it is plus 1 whole square. So minus 4 plus 1 is minus 3 whole square plus 4 plus 1 is 5 square. So minus 3 whole square is 9, 25, 5 square is 25. So 9 plus 25 is root 34. Okay. So let us check the last side AD. So AD is equal to square root of, this is x1, y1, x2, y2. So minus 4 minus 1. So minus 4 minus 1 whole square plus 4 minus 7. 4 minus 7 whole square, which is equal to minus 4 minus 1 is minus 5 whole square plus 4 minus 7 is minus 3 whole square. So minus 5 whole square is 25, minus 3 whole square is 9. So 25 plus 9 root 34. So we got AB is equal to root 34, BC is equal to root 34, CD is equal to root 34, AD is equal to root 34. So we got all sides equal. Now we have to prove all the diagonals as equal. So let us do that in the next page. So far we got AB is equal to BC is equal to CD is equal to AD is equal to root 34. So we proved all sides are equal. Now we have to prove the diagonals AC and BD are equal. So if they are equal, then these 4 points form a square. If they are not equal, they will form a rhombus. So let us check for AC and BD. So for checking AC, we have to take the coordinates A 1 comma 7 and C minus 1 comma minus 1. So AC equal to square root of x2 minus x1. So x2 is minus 1 minus x1 is 1. So x2 minus x1 whole square plus y2. y2 is minus 1 minus y1 is 7 whole square. So minus 1 is minus 2 whole square plus minus 1 minus 7 is minus 8 whole square. So minus 2 whole square is 4. 8 whole square is 64. So 64 plus 4 you will get 68. That is root 68. Next let us check for the diagonal BD. So what is B? B is 4 comma 2 and D is minus 4 comma 4. So what is the distance between BD? BD is equal to square root of x2, which is minus 4, minus x1, it is 4 whole square plus y2 4 minus y1 is 2. So minus 4 is minus 8 whole square. 4 minus 2 is 2 square. So minus 8 whole square is 64. 2 square is 4. So 64 plus 4 we will get 68. So AC is equal to root 68. BD is equal to root 68. So we get AC equal to BD equal to root 68. So all sides are equal and diagonals are equal. So this is A and this is B. So if we keep this as A and B, so let us say from A and B, ABCD is a square. Okay children, I hope you can understand. So moving on to the next example in the next page. So what is given? The figure shows the arrangement of desk in a classroom. Ashima, Bharti and Kemla are seated at A of 3, 1, B of 6, 4 and C of 8, 6 respectively. Do you think they are seated in a line? Give reasons for your answer. So, this figure shows the arrangement of desk. So, they have arranged the desk. There are 3 children, Ashima, Bharti and Kamala. So they are seated at 3, 1. So this girl is seated at 3, 1. Bharti is seated at 6, 4. Kamala is seated at 8, 6. We have to show that they form a line. So if you join this, it should form a line. So for this condition, so that is it is in collinear. So we should get AB plus BC should be equal to AC. So the condition is AB plus BC should be equal to AC. So this is the condition to be seated in a line. Okay. So let us check this. So what are given? A is 3, 1, B is 6, 4 and C is 8, 6. So what is AB? AB is equal to square root of formula is x2 minus x1 the whole square plus y2 minus y1 whole square. So x2 is 6 and x1 is 3. So 6 minus 3 whole square plus y2. It is 4. y1 is 1. So 4 minus 1 whole square. 6 minus 3 is 3. 3 square plus 4 minus 1 is 3. So 3 square plus 3 square. 3 square is 9. 3 square is 9. So it is nothing but root 80. So root 18 can be written as square root of 9 into 2. So 9 is a perfect square. So root 9 is 3 root 2. Okay. So next let us check for BC. So BC equal to BC. So this will be what? X2. So 8 minus 6 whole square plus y2 minus y1. 6 minus 4 whole square. So 8 minus 6 is 2. So 2 square plus 6 minus 4 is 2. 2 square. So it is nothing but 2 square is 4. 2 square is 4. So root 8. So root 8 can be written as 4 into 2. So it is nothing but 2 root 2. Okay children. So next we have to check AC. So AC is equal to, so this A and C. So 8 minus 3 whole square plus 6 minus 1 whole square. So 8 minus 3 is 5 square plus 6 minus 1 is 5 square. So 5 square is root 25. 5 square is 25. So root of 25 plus 25 is root 50. So root 50 can be written as 25 into 2. So root of 25 is 5. So it is 5 root 2. So we got AB is equal to 3 root 2, BC is equal to 2 root 2 and AC is equal to 5 root. So let us check the condition AB plus BC. So AB plus BC. So AB plus BC is 3 root 2 plus 2 root 2. So 3 root 2 plus 2 root 2 is 5 root 2 which is equal to AC. So we got AB plus BC is equal to AC. Then if it is so, then they form a line. So A, B, C form a line. Okay children, can you understand? So moving on to the next problem. Find a relation between x and y such that the point x comma y is equidistant from the points 7 comma 1 and 3 comma 5. So there is a point x comma y. So point x comma y. So this point is equidistant from a two points 7 comma 1 and b 3 comma 5. So if it is so, we have to find out the relation between x and y. Okay. So let us name the points. So let this be a of 7 comma 1 and this is b of 3 comma 5. So what they said, this point is equidistant from a and b. So if it is equidistant, then we will have AP is equal to BP. Okay, what is P? P is nothing but x comma y. So AP is equal to BP. So second point is P on both sides. So this will be x2, y2. And these points will be x1, y1. This will also be x1, y1. So first AP. So distance formula is square root of x2 minus x1 whole square plus y2 minus y1 whole square. So this is the distance formula. So square root of x2. x2 is x. So x minus x1 is 7. So x minus 7 whole square plus y2 is y. So y minus 1 the whole square which is equal to BP. So x minus 3 the whole square plus y minus 5 whole square. So on squaring, if you square both sides, these roots will get cancelled. So you will get x minus 7 whole square plus y minus 1 whole square equal to x minus 3 whole square plus y minus 5 whole square. So all are of the form a minus b whole square. So what is a minus b the whole square? It is nothing but a square minus 2ab plus b square. So it will be x square minus 14x plus 49 plus y square minus 2y plus 1 equal to x square minus 6x plus 9 plus y square minus 10y plus 25. So here x square plus x square and plus x square. So this is same on both sides. It will get cancelled in the same way. Plus y square and plus y square gets cancelled. So now collecting the terms, we have minus 14x. On the other side we have minus 6x. So this will become plus 6x. And y term we have minus 2y. On the other side minus 10y. So this will become plus 10y. So what are the constants? 49 plus 1, which is 50. On the other side we have 9 plus 25. So 9 plus 25 is 34. So plus 34, it will become minus 34 equal to 0. So first taking the x term is minus 14x plus 6x. So it is minus 8x. Next to y term minus 2y plus 10y. So 10 minus 2, 8. So plus 8y plus 50 minus 34 is 16. So plus 16 equal to 0. So we have minus 8x plus 8y. This plus 16 can be written as minus 16 on the other side. So we are multiplying with negative. So if you multiply with negative, we will get plus 8x minus 8y equal to 16. So all are multiples of 8. So dividing by 8, you will get x minus y equal to 2. So because 8 is divisible one time, this 8 is divisible one time, 16 is divisible two times. So x minus y is equal to 2. So this is the relation between the points x comma y. So this relation satisfies AP is equal to BP. Okay children, I hope you can understand. So moving on to the next example in the next page. So example 5. Find a point on y-axis which is equidistant from the points A of 6, 5 and B of minus 4, 3. So here there is a point on y-axis. So there is a point P on y-axis such that this point P is equidistant from A 6, 5 and B minus 4, 3. So this point P is equidistant from A and B. So how will be the points in y-axis? So in y-axis, x coordinate will be 0. So some value for y. So this is the way the point will be in y-axis. So if it is equidistant, we have AP is equal to BP. So they gave A as 6, 5 and B as minus 4, 3. So the point P is 0, y. So if it is equidistant, we should have AP is equal to BP. Okay, so if it is so, then we have to find the value of y. Okay, so we have to find a point on y-axis. X coordinate is 0. Just we have to find out the value of y. So this will be x1, y1 and this will be x2, y2. So distance between AP. So distance formula is square root of x2 minus x1 whole square plus y2 minus y1 whole square. So applying this distance formula, AP is square root of x2 minus x1. So 0 minus 6 whole square plus y2. It is y minus y1 is 5. Y minus 5 whole square equal to square root of BP. So then this will be x1, y1 and this will be x2, y2. So BP is x2 minus x1, 0 minus x1 is minus 4 whole square plus y2, y minus y1 is 3 whole square. So if we square on both sides, this root gets cancelled. So root of 0, root gets cancelled. So we should not write the root. So there will be 0 minus 6 whole square. So it will be minus 6 whole square plus y minus 5 the whole square, which will be equal to 0 minus minus 4. It will be 0 plus 4. 0 plus 4 is 4. So 4 square plus y minus 3 whole square. So what is a minus b the whole square? A minus b whole square is a square minus 2ab plus b square. So applying this, minus 6 whole square is 36. Y minus 5 whole square is y square minus 10y plus 25 equal to 4 square is 16. Y minus 3 whole square, y square minus 6y plus 9. So this plus y square and plus y square gets cancelled. So collecting the y term, we have here minus 10y. On the other side, we have minus 6y. When we change the side, it will become plus 6y. So what about the constants in this? 36 plus 25 is 61. On the other side, we have 16 plus 9. So 16 plus 9 is 25. So minus 10y plus 6y. So it is minus 4y equal to 25. This plus 61 will become minus 61. So minus 4y equal to 25 minus 61 is minus 36. So then y will be equal to minus 36 divided by minus 4. So this minus 4 is in product. When we change the sign, it will be in division. So the negatives gets cancelled. 36 by 4. So 1 4s are 4, 9 4s are 36. So y is equal to 9. So the point P is 0, comma 9. So point P is at equidistance from A and B. Okay. So this point satisfies AP is equal to BP. Okay children. I hope you can understand all the problems. So if you like the video, just share, like and subscribe. And thank you for watching.